Imagine everything you've ever known, every star, every galaxy, every atom in your body, compressed into a single point. No space, no time, no light, only potential. Then, in an instant beyond comprehension, it happened. The birth of time, the spark of matter, the beginning of everything. The Big Bang wasn't an explosion in space, it was the explosion of space itself. An expansion so vast, so total, that the very laws of nature were rewritten in its wake. We live in the aftermath of that single moment, a cosmic echo stretching across 13.8 billion years. But to understand who we are and where we came from, we must go back to the very first second and witness how the universe itself came alive. The story begins with a paradox. A moment so extreme, our understanding collapses. Temperatures reach 1032 Kelvin, energy so dense that the four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were one. This is the Planck era, the smallest, most mysterious sliver of time in cosmic history. No atom, no light, no particles existed yet. Just a roiling quantum foam where fluctuations in space-time itself rippled like waves in an unseen ocean. Here, even quantum mechanics and general relativity, the pillars of modern physics, stop working together. To understand this epoch, we would need a theory of quantum gravity, something scientists still chase today through string theory and loop quantum cosmology. This fraction of a second is unknowable, but it set the foundation for everything. It is the breath before the universe spoke. Then, something unimaginable happened. In a burst of exponential expansion, the universe grew from smaller than an atom to larger than a galaxy in a heartbeat. Space itself stretched faster than light, an event we now call cosmic inflation. This wasn't an explosion into space, this created space. Microscopic quantum fluctuations were pulled across cosmic scales, freezing into subtle patterns, variations in density that would one day become galaxies, stars, and planets. The inflationary universe was smooth, flat, and astonishingly uniform. Yet, those faint ripples from the earliest vibrations still linger today, imprinted in the cosmic microwave background, the universe's baby picture. But there's still one haunting mystery. What caused inflation to start, and why did it stop? Some scientists believe it was triggered by a scalar field, an energy form now extinct. Others think inflation never ended completely, spawning countless bubble universes in a grand multiverse. Our universe may just be one spark among an infinite sea of cosmic creations. As the universe cooled, energy began to transform into matter. Photons collided, creating particles and antiparticles in a furious storm of annihilation and rebirth. But in the end, a tiny imbalance, one extra particle for every billion antiparticles, was enough to tip the scales in favor of matter. Without that sliver of asymmetry, there would be no stars, no galaxies, no us. Protons and neutrons formed as the temperature dropped below 1 trillion degrees. Moments later, Big Bang nucleosynthesis began, the first cosmic chemistry. In the first 3 minutes, the universe created hydrogen, helium, and traces of lithium, the first elements in existence. These humble atoms became the building blocks of everything that followed, the fuel for stars, the scaffolding of galaxies, and the matter that would one day compose life. By the time the universe was 5 minutes old, the furnace went dark. No new elements could form until the first stars took the stage hundreds of millions of years later. The universe had its ingredients. Now, it just needed time to cook. For hundreds of thousands of years, the young universe glowed, a hot fog of plasma where light and matter were locked together. But as it expanded and cooled, protons captured electrons, forming the first neutral atoms. Finally, light could move freely. This light, still traveling through space today, is the cosmic microwave background, or CMB, a faint afterglow of creation itself. It's the universe's oldest relic, a fossil snapshot of what the cosmos looked like when it was only 380,000 years old. But once the CMB was released, everything went dark. Stars hadn't yet formed. There were no galaxies, no light, just endless hydrogen and helium drifting in the dark. This was the cosmic dark ages, a time of silence and shadow. Yet even in that stillness, gravity was at work. Minute fluctuations from the inflationary period began to grow, drawing matter together into vast filaments of invisible dark matter. These cosmic webs became the skeleton of the universe, the invisible framework upon which galaxies would one day form. Darkness wasn't the end. It was the waiting stage before the first light returned. Then came the first sparks. Deep within dense clouds of hydrogen, gravity squeezed matter tighter and tighter until nuclear fusion ignited. The first stars, known as population 3 stars, were born, massive, brilliant, and short-lived. These were giants, 100 to 300 times the mass of the sun. They burned hot and fast, flooding the universe with ultraviolet light and ending the dark ages. When they died, they did so violently, collapsing into black holes or exploding as supernovae, forging the first heavier elements, carbon, oxygen, and iron. These first elements are the foundation of life. Without them, there could be no planets, no biology, no chemistry, only hydrogen and helium adrift in the dark. Every breath you take, every cell in your body, every planet and star you see, all of it was born from the ashes of these first stars. We are, quite literally, children of cosmic fire. But their light did more than illuminate the void. It reionized the hydrogen gas that filled space, transforming the universe from opaque to transparent. And it prepared the way for the next great transformation, the birth of galaxies. The young universe was finally bright, but chaotic. Stars were forming everywhere, colliding and merging in turbulent clusters. Gravity pulled stars into vast structures bound by invisible dark matter halos, the birthplaces of the first galaxies. Over millions of years, these galaxies collided, merged, and grew into the immense spirals and ellipticals we see today. Each collision created shockwaves of star formation, massive bursts of energy and light that sculpted cosmic architecture. Galaxies grew in clusters, forming filaments that stretched for billions of light years, the great cosmic web. But new discoveries are rewriting this story. The James Webb Space Telescope has detected galaxies so bright and well-formed that they seem to have appeared far earlier than expected, just 300 million years after the Big Bang. These findings challenge our understanding of cosmic evolution. How could galaxies so large exist so soon? Some astronomers now believe early black holes may have accelerated star formation, or that dark matter played an even greater role than we thought. Whatever the truth, it suggests the universe evolved faster and more efficiently than our best models predict. The universe was learning to organize itself. The age of chaos was over. The age of structure had begun. As time passed, galaxies matured. Stars lived, died, and recycled their material into new generations. Massive black holes grew at their centers, powering quasars, the brightest beacons in existence. Galaxies merged into clusters, bound together by gravity but separated by dark energy, the mysterious force accelerating the expansion of the cosmos. About 9 billion years after the Big Bang, the universe entered its modern phase. Spiral galaxies like our Milky Way took shape, calm, stable, and filled with rich chemical diversity. Planets formed, moons circled, solar systems stabilized. On one small world orbiting a modest star, chemistry became biology. Biology became consciousness. And consciousness began to look back at the sky and wonder where it came from. The atoms that make up our bodies were once part of stars that lived and died billions of years before Earth formed. We are the universe becoming aware of itself. Today, the universe is 13.8 billion years old. Galaxies continue to drift apart, carried by the ever-accelerating expansion of space. Dark energy dominates, its nature still completely unknown. We can only watch as distant galaxies fade beyond the cosmic horizon, forever out of reach. We live in a transitional moment, old enough for galaxies to exist, young enough for the stars to still shine. The universe's large-scale structure is vast but fragile, a web of filaments and voids spanning billions of light years. In a few trillion years, all of it will vanish beyond our view. Future civilizations may see only their own galaxy and think that is all there ever was. But for now, we can still look up and see the ancient light of the beginning, traveling across time to tell its story. The more we learn, the more the universe surprises us. We have mapped its history, but its origins remain a puzzle. What triggered inflation? Was it a quantum fluctuation or the birth of a multiverse? What is dark matter, the invisible glue that shapes galaxies? And what is dark energy, the unseen hand that tears them apart? Even time itself may not be what we think. Some cosmologists suggest that our universe didn't begin with the Big Bang. It was the rebound from a previous collapsing universe, a big bounce. Others imagine eternal inflation, spawning infinite worlds, each with its own laws of physics. Whatever the truth, one thing is certain. The universe is not static. It's a living, evolving entity, and we are a part of its story. From a fraction of a second to 13.8 billion years, the universe has transformed from pure energy into the vast, intricate cosmos we see today. It has turned nothingness into galaxies, gas into stars, and chaos into order. It has turned stardust into beings capable of asking why. The same hydrogen that burned in the first stars now flows in your veins. The same photons that burst from the dawn of creation still echo in your microwave oven. The universe is not out there. It's within you. Every atom in your body was forged in ancient stars that lit up the dark ages. You are not separate from the cosmos. You are the cosmos, made conscious. And perhaps that's the most profound truth of all. The Big Bang never really ended. Its echo lives on, in galaxies, in starlight, and in every thought that dares to ask how it all began.